Yeah, good evening, children. Good evening, online students, Roshni, Anugraha, and Akshada. Good evening. Yeah, last class I did mention that I started volumes and surface areas because my presentations on polynomials, I was telling that I'm altering the presentations, separating the deleted portions from the portions we are continuing with. My Word files are ready, but my PPTs are not ready. So I thought I'll finish it by today, but not possible. It was not possible. So we are continuing with volumes and surface areas. Definitely by the next class on Thursday, I will finish my work. The presentations will be ready and we'll continue and finish polynomials. Okay. Okay, so this question, Rashid got a plain top as his birthday present, which surprisingly had no color, which had no color on it. He wanted to color it with his crayons. The top is shaped like a cone. You can see the figure. Okay, the top is shaped. The top is, the top which you, what do? You wind thread, no, around the top and you leave it on the floor. It spins. Have you ever used a top? Yes? Yeah, so we wind a rope from the base pole. We bind not a rope, a slightly thick thread. Okay, not a rope. So you wind it and then you need to hold it like this and just leave it and pull it back. Just leave it on the floor and pull your hand back. So then it spins. Yeah, and then there's top fighting and all that. Two tops. you spin yours, I spin mine, and then whichever top falls, you lose. Which one still spins on the floor is the winner. So like that. All these are what do you say? Traditional Indian indoor-outdoor games, forgotten, with a lot of value, but we've forgotten. So this question reminds us. Okay, the nail in the top is missing. What is missing in the top is a nail. There'll be a nail here. Yes or no? There'll be a nail. There's a nail. So the nail is that's the pivot and goes. Okay. So no, he wanted to color it with his crayons. The top is shaped like a cone. Yeah, you can see it's shaped like a cone, surmounted by a hemisphere. Surmounted by a hemisphere. Surmounted by a hemisphere. The entire top is 5 centimeters in height. The whole top is 5 centimeters in height. And the diameter of the top is 3.5 centimeters. Diameter meaning from here to here. So the diameter of the hemisphere, the diameter of the cone, both are the same. The two solids here are hemisphere and cone. Hemisphere and cone are the two solids. And the diameter of the hemisphere and the diameter of the cone. From where is the noise? From outside. Huh? Okay. Find the area he has to color. Find the area he has to color. Okay, ignore that. You focus on my sound. Okay. Find the area he has to color. So what of the top is exposed? The CSA of the cone and the CSA of the hemisphere. Now, CSA means what? If the circular face of the cone and the circular face of the hemisphere, they are also visible. If the circular face of the hemisphere and the circular face of the cone, if both of them are visible, then you can find the total surface area. Here it is only CSA because the circle of the cone and hemisphere is not visible, correct? This is CSA. If this is also visible, then it is TSA. But this one is not visible. No, the hemisphere is stuck on it. This one is not visible. Only this one is visible. So CSA. For the hemisphere, only this one is visible. This circle of the hemisphere is not visible because it's stuck to the cone. This is not visible. Only this is visible. So it is only CSA. So the area he has to color is the CSA of the cone plus the CSA of the hemisphere. All right. Now for the hemisphere and the cone, please write out the values. 1 minute. Radius, height, slant height. For area, for cone, for area, you will need slant height. You don't need this height. You need only slant height. Okay. Only for volume, you need perpendicular height. For area, you need slant height. Because what is area? It is pi r L or pi r into r plus L. Pi r L or pi r into r plus L. All right. But volume is what? 1 by 3 pi r square h. What's volume? 1 by 3 pi r square h. See, you need the value of h. The perpendicular height of the cone is only for the volume, is only for finding volume. The slant height of the cone is for area. You don't have perpendicular height here in area. H you don't have in the area formula. H you have only in volume formula. Okay, so here it is CSA of the cone. No? So you need the value of L. What is R? 3.5 by 2. For the hemisphere, 3.5 by 2. For hemisphere, only radius you need. You don't need anything else. You need only radius. 3.5 by 2. Cone, 3.5 by 2. Then what's the total height? 5. What is the total height made up of? It is a hemisphere's height plus the cone's height. Plus the cone's height. Together is 5. The hemisphere's height plus the cone's height. Together is 5. What's the height of the hemisphere? What's the height of the hemisphere? It's the radius. The radius of the hemisphere. The radius of the hemisphere is the height of the hemisphere. What is the depth of the hemisphere? What's the depth of the hemisphere? The radius. For a hemisphere, for a hemisphere, the radius is equal to the height. We don't know that? We know, right? Okay, so what's the height? So height of cone plus height of hemisphere is equal to total height. Height of cone plus height of hemisphere is equal to total height. What's the height of the cone? We don't know, h. Plus what's the height of the hemisphere? 3.5 by 2, because 3.5 is the diameter. Height is the radius, so 3.5 by 2 is equal to the total height 5. So from this you can find the value of h. I've calculated. You can see 3.5 by 2 is 1.75. So it will be 5 minus 1.75, which is 3.25. All right. Then using Pythagoras theorem, you should find the value of L. You should find the value of L using Pythagoras theorem. And then use it in the formula. You should keep all these values ready. Then you must use the formula. CSA of cone, pi RL, plus CSA of hemisphere, 2 pi r square. Will be the area he has to color. Yeah. Please understand and work. Don't blindly copy. You have to write the question. This is NCERT exercise 12.1. NCERT exercise 12.1 it is. Example 1. Please write the question and work the answer. The best thing is as you write, you should understand. As you write, understand what you're writing. Any question, ask me immediately. Completed. So how do we find the square root of 13.625? Tell me. How do you find the square root of 13.625? So you'll have to pair it, right? We'll have to pair the digits. There's a decimal point. Before the decimal point in this direction, after the decimal point like this. So you can add 1 0. Square root, the long division method, 8th standard. All right. So now 2 2s are is 4. 3 3s are 9. 4 4s are 16. So it is here we have 13. The first pair is 13. So 3 3s are 9. 4 is a remainder. The decimal point. The next pair comes down. Sorry, not here the decimal point. Sorry. Decimal point. And the next pair comes down. The next pair comes down. Correct? 3 3s are 9 because 4 4s are 16. It's more than 13. So 3 3s are 9. 2 2s are 4 is too small. 3 3s are 9. 4 is a remainder. Decimal point. You'll have to bring down 62, which is after the decimal point. So place a decimal point here. Bring down the digits 6 and 2. Now double the quotient. Double the quotient. 3 into 2, 6. Or if you have learned like plus 3, I don't know how you have learned it. Double the quotient. Okay, if you've forgotten, it's double the quotient. What do you see in the quotient? You see 3, right? Double it. 3, double it. 6. Write that here, 6. Now, whatever digit you place here, you must place the same digit here. Whatever digit you place here, you should write the same digit here. So if you put 1 here, you should put 1 here also. If you put 2 here, you should put 2 here also. 3 here, then 3 here also. So it will be, the products will be 61 into 1 or 62 into 2, 63 into 3, 64 into 4. They are the products you will get. See, because if you put a 4 here, you should put a 4 here also. 64 into 4. If you put a 5 here, you should put a 5 here also. 65 into 5. So what is 65 into 5? 5 2 carried over, 325. But we have 462. So let's go a little ahead. 66 into 6. 6 6 are 36. 3 carried over, 39. Little more than. So 67 into 7. Right? So 7 7 are 49. 4 carried over, 42. And what is this? 46. Huh? Correct? But it's more than 462. It's more than 462. I said whatever digit you place here, you must place the same digit here. All right. So 65 into 5 is 325. 66 into 6 is 396. 67 into 7 is 469. Is my multiplication correct? Yeah. So 469 is more than 462. So which is the number just less than that? 396. So 66 into 6 is 396. The remainder 66. Bring the next pair down. Bring the next pair down. 5 0 comes down. Again, double the quotient. What do you have in the quotient? 3 6. Forget the decimal point. What do you have in the quotient? 3 6. Double the quotient into 2. 72. That's what you should write here. 72. Again, whatever digit you place here, you should place the same digit here. So if you write 721 into 1, 722 into 2, 723 into 3, like that. Whatever digit you place here, you must place the same digit here. So 725 into 5. All right. Or 726 into 6. So I've written 9 there. So it is 729. Let me check 8. 728 into 8. $728 into 8. 8 8 is 64. 6 carried over. 8 is 16. 22 2 carried over. 8 7 is 56. 58. 729 into 9. Are you following? All of you? 729 into 9. 9 9s are 81. 8 carried over. 9 2s are 18 plus 8. 26 2 carried over. 9 7 is 63. 65. 65. So it is 9. 729 into 9 is 6561. You can stop. Simply get 1 or 2 decimal points and stop. That's all. So 3.69. You should know how to perform this long division. Otherwise, you'll be stranded. If you don't know, see, if you don't know to find the square root of 13.625, just for example, you don't know, then what if you do in the exam? What is 13? 13 is between what? 3 3s are 9 and 4 4s are 16. So it'll be 3 point something, right? 3 point something and proceed. You should know how to find the division, square root by long division method. But what is this? 13.625, right? It's between 3 3s are 9 and 4 4s are 16. It's between 9 and 16. So what will be the square root of 13.625? Some 3 point something. It can be 3.0 something also. See, 3 point something. No, I'm not saying just write some value like 3 point something and proceed. But if you don't know, if or you carelessly did not bother to recall and learn how to find the square root, you should do something. No, so write 3 point something and proceed. Whether you will get marks, I don't know. But this is the long division procedure. Should find the square root like this. That's what we found here. So in the step in the number is not easy. It comes after calculation. So square root of 13.625 kapra, inga you see 3.69. But how did the 3.69 happen? In the working column, நம்ம பண்ணிருக்கணும். இது 8th standard, இதை நம்ம பண்ணிருக்கணும் working column. அப்ப இதுக்கு எவ்வளவு time வேணும்? So that's how we take long time to, complete questions from volumes and surface areas, particularly when this cone is there. Because you'll have to use Pythagoras theorem here. If it's a perfect square, in the imperfect square, it will take some time. So 3.69, I've rounded to 3.7. So where are we now? We have found the slant height. Correct? Well, from where did I start explaining? From here. Oh, I think I already told you about all this, right? All right. So this is how we find the slant height. And the area to be colored, again, we understood this also. Now, there are two ways of working this. Here, what I've done is I've substituted the values. I've not taken the value for pi. Can you see that? I found it in terms of pi. Then I put the two pi's together. I got 12.6 pi. Once for all, I use the value of pi, 22/7. The other way of doing it is pi r L plus 2 pi r square. You can take out common. What's common? Pi r is common. So L plus 2r. Like this also you can do. So it will be pi is what? 22/7 into r is 1.75 into L 3.7 plus 2r. 2r na diameter 3.5. எப்படியும் calculate பண்ணு. Common எடுத்தும் calculate பண்ணு. Now common எடுக்கல, but I have not used the value of pi. I've got this answer in pi, this answer also in pi. Then put them together, I got an answer in pi. Then once for all, I've used 22/7. The alternate working is you can take out common. Pi r is common. Then you get L plus 2r in the bracket and you can substitute the values and calculate it. Yeah, see, do you understand that? See, the entire top is 5 centimeters in height. The total top, the top is the whole thing. This is 5 centimeters in height. That's not the height of the cone. 5 is not the height of the cone. That's the height of the top. What do you mean by the height of the top? It's the height of the hemisphere and the height of the cone. What's the height of the hemisphere? Whatever is the radius. What's the radius? 1.75. So 5, the total height 5 minus the height of the hemisphere 1.75 is the height of the cone 3.25. Completed online, children? So you can see this block here. It's made of two solids, cube and hemisphere. The bottom is a cube, the top is a hemisphere. The base of the block is okay. The edge of the cube is 5 centimeters, and the diameter of the top, that is a hemisphere, is 4.2. Find the total surface area of the block. So again, total surface area, you should not use the total surface area formula. See, not to get confused like this. Find the TSA of the block. No, so what we'll think, there is cube. What's the TSA formula? 6a square. There is hemisphere. What's the TSA formula? 3 pi r square. Come on, let's add these two. No, it's wrong. Don't be, misled by that word total. Find the total surface area of the block. So immediately, total surface area. What's the TSA of the cube? 6a square. What's the TSA of the hemisphere? 3 pi r square. So find these two and add. It's wrong. Whenever we have to find surface area or total surface area in combination of solids like this, they are asking you to find the area that is available to be painted, where all you can paint. The total, whatever area is visible outside. உங்களுக்கு வெளியில இந்த சாலிட் இப்படி எடுத்து பார்த்தா எங்கெல்லாம் ஏரியா என்னெல்லாம் தெரியுது உங்களுக்கு, whatever surface is visible. If you have to paint it, where all you can paint, that area they want you to find. That is the total surface area. Total surface area does not mean write the TSA formula for cube, write the TSA formula for hemisphere, add both, and that's the TSA of the solid. It's not like that. So if you lift the cube and see, எங்கெல்லாம் paint பண்ணுமோ அது, அந்த ஏரியா எல்லாம் calculate பண்ணும் together. Now, if you look at the top of the cube, this is the top. This is the top of the cube. The top of the cube. Okay. What is the what's the maximum circle it can have of diameter? 5 centimeters. Because the edge of the cube is 5, no? It's a square. The top is a square. The top of the cube is a square. And the biggest circle that can be inscribed, the biggest circle that can be inscribed on the top square is a circle of diameter 5 centimeters. அதுக்கு மேல circle அங்க போட முடியாது. 5 centimeters இல்ல 5 centimeters கம்மி radiusல நீங்க மேல ஒரு circle, you can have a circle. Now here we have a hemisphere whose diameter is 4.2 centimeters. It's less than 5. The circular mouth of the hemisphere has a diameter of 4.2 centimeters only. So on the top, if you see, that mouth of the hemisphere is like this. So ingalam konja edam irukum. It will not be like, I'm saying it will not touch the edges like this. It will not touch the edges like this. The mouth, the hemisphere is inverted. The hemisphere is inverted. So the mouth of the hemisphere sits on the top of the cube. Okay. It will not sit like this because the diameter of the hemisphere is not 5. Only if it is 5, it'll be like this. It's not 5, it's less than 5. So it's 4.2. The diameter is only 4.2. So the top of the cube, you can see some area here like this, and then the cube, and then the hemisphere inverted on it. So now imagine this figure. So cube, bottom area, cube, bottom area, fully visible. The 4 sides, the 4 lateral surfaces, no disturbance, fully visible. If you have to paint, bottom, yeah, you can paint it fully. The 4 lateral walls or the 4 lateral surfaces, you can paint it fully. On the top, no, full area is not available to be painted. Then what area is available to be painted? Only this area is available. So how do you find this area? This area is area of the square minus the area of the circle. On the top, it's a square. What's the total area available on the top? If your terrace is like this, what's the total area of your terrace by a square? Because it's a square, no? So a square. Now, supposing there's something here and you cannot go there and play. maybe some garden or something. There's a garden here, so you cannot go here and play. You can play only here. You can play only here, or you can use only this region. What's the area there? It will be the total area A square minus the area occupied by the circle, pi r square. This is the remaining area. This is the remaining area. Bottom area fully available. 4 walls fully available. On the top, not fully available. What's the area of the top? A square. What is not available? Pi r square. If you subtract, this is available on the top. So you have painted the bottom A square, you have painted the 4 walls, 4A square. On the top, whatever is available, you have painted. What is available? Totally A square is there, but pi r square you cannot paint. The mouth of the hemisphere takes up that area, no? That you cannot paint. So A square minus pi r square, this is the remaining area. Then what else you have to paint? The CSA of the hemisphere you have to paint, right? The CSA of the hemisphere, that you'll have to paint. So plus 2 pi r square. Keep on adding the surfaces you have to paint, that's all. So you have to, whenever you're finding area, it should be like you have the block in your hand, you should visualize it. You have the block with you and start imagining where all you should paint. Keep adding those surfaces, the area of those surfaces. Shall we come again? Is the bottom area completely available? How is the solid? The solid is a cube. And on top of the cube, there is a hemisphere. What is the edge of the cube? 5 centimeters. So what is the maximum diameter the circle on the circle can have? 5. But no, this hemisphere, the mouth of the hemisphere has a diameter of 4.2. So on the top, the mouth of the hemisphere will be like this. So on the top, what area is available? This area outside the circle. The area outside the circle, but inside the square is available. The area outside the circle, inside the square is available. Okay. So A square is the bottom. 4A square is the 4 walls. We painted. Now we have come to the terrace, the top. On the top, you see that you can't paint fully. You can paint only this region. So how will you paint this region? How will you paint this region? The total area is A square on the top. Minus what is not available because the hemisphere is, on the cube. That pi r square area is not available. So take it away. This is the remaining area. This is the area of this region. A square minus pi r square. So that you can paint. That is only this area. You will paint here. That is only A square minus pi r square. Now you think you're done? No. That hemisphere's CSA is still not painted. Add that also. So add that. Hemisphere CSA is 2 pi r square. So simplify this. A square plus 4A square is 5A square plus A square minus pi r square plus 2 pi r square. So it will be 6A square plus pi r square. 6A square minus, plus pi r square. 6A square plus pi r square. Substitute the values of this and calculate. You can also imagine, you can also say the TSA of the cube is 6A square, no? The total surface area of the cube is 6A square. In the 6A square, எல்லாமே இருக்கு, but மேல ஒரு சர்க்கிளோட ஏரியா மட்டும் இல்ல. So minus pi r square. அப்படியே யோசிக்கலாம். 6A square full இருக்கு ஏரியா பெயிண்ட் பண்றதுக்கு. ஆனா அந்த 6th ஃபேஸ்ல மட்டும் ஒரு pi r square ஏரியா இல்ல பெயிண்ட் பண்ண முடியாது. அப்ப அதை மட்டும் எடுத்துருங்க minus pi r square. அப்புறம் அந்த ஹெமிஸ்பியரோட சிஎஸ்ஐ பெயிண்ட் பண்ணோம். அதை ஆட் பண்ணுங்க. எதெல்லாம் பெயிண்ட் பண்ணுமோ அது எதெல்லாம் இருக்கோ அதை ஆட் பண்ணும். எது இல்லையோ அதை சப்ட்ராக்ட் பண்ணும். ஸோ 6A ஸ்கொயர்ல என்ன இல்ல? அந்த மேல அந்த 6th சர்ஃபேஸ்ல வந்து ஒரு pi r ஸ்கொயர் ஏரியா இல்ல. அதை எடுத்துடணும். இன்னும் வேற என்ன இருக்கு? சிஎஸ்ஐ ஆஃப் த ஹெமிஸ்பியர் இருக்குன்னு ஆட் பண்ணணும். பெயிண்ட் பண்ணோம்னா ஆட் பண்ணணும். பெயிண்ட் பண்ண முடியாதுன்னா சப்ட்ராக்ட் பண்ணணும். So like this also you can get 6A square plus pi r square. Yeah. Good. You must cancel, huh? 7 ones are 7, 0.3 times. Have you done that? Have you cancelled? You need to cancel, children. How do 7 ones are 7, 0.3 times. Then 22 into 0.3 into 2.1 is 13.86. Why are you always sleepy? You wake up very early in the morning. What time do you wake up? 4. So by now, you normally sleep early, is it? It's a good habit, but yeah. Okay. So I'm not talking about this question or the working here. Now imagine this situation. You have a cuboidal. You have a cuboidal block. Okay, say the length is. So this I'm not explaining, children. I think this clear. Okay, now this situation, you have a cuboidal block. Okay, say length 10 centimeters, breadth 8 centimeters, height 6 centimeters. Okay, and you're making say 3 conical cavities. 3 conical cavities. That means how will I draw that? Okay, I'll just. These are the conical cavities, okay? Okay. So you have a cuboidal block made of wood, dimensions 10, 8, and 6. You have made 3 conical cavities on the top. Say the radius of the cone, this one is 10, right? So 10, say like 2, 2, 2, 2. So 8 is gone. So what is remaining? 2 is remaining, right? Let me give very, very small value. Okay, I'll increase this value. I'll increase this and I'll be safe. Make it 20. So if I the cone, if I say radius is 1 centimeter, so diameter is 2, 4, 6. Then what is remaining? 14. Okay, safe it is. Okay. So I'm saying radius is 1 centimeter for the cone and the height is 2 centimeters. Okay. So you have a cuboidal block of wood, dimensions here. You're making 3 conical cavities on the top. Conical depressions, conical. The shape of a cone. Okay. You make depressions meaning cone shape, you're removing the cone. You make a you cut out a cone, you remove the cone. So there'll be a conical depression, conical cavity. So 3 conical cavities you make. That means what? You cut and you remove a cone from the top. You're removing a cone from the top. Okay, 3 conical cavities. The radius of the cone and the height of the cone is given to you. Now I want you to find the expression to find the total surface area of the remaining block. Total. TSA of the remaining block. What is the original block? The solid cuboid. The solid cuboid is original block. Now you've made the 3 conical cavities. What is the total surface area of the remaining block now? Find the expression. Like this, I want you to find, children. See, I want you to give an answer like this. Like this. Like we generated the formula like this, right? For this situation. Adu madri, give me the expression. Give me the formula to find the TSA of the remaining block. Do it. Let me know when you're ready with the answer. Yeah. Yeah, I want the answer first from any one of the online students. Roshni, Aniruddhan, Akshada, Anugraha. One of you please answer. You ready, Pratish? That's okay. Formula. No, it's okay if you tell me in words also. You tell me in words. You don't have to even use the formula and tell me. Just tell me like you'll have to add this area, then this one, subtract this one. That is enough for me. See, once you understand that formula, you can memorize and fill it. What? 6 into? Don't tell me in words. Okay, what formula you want? For CSA, you want to know the, so for the cone, you want to know the CSA, is it? Pi RL. Tell me what you want to do. Pi RL. Then what else you want? The TS of the cuboid, huh? 2 into, you wrote 2 into L plus B, is it? That's rectangle. 2 of LB plus BH plus LH. Okay. No, this one is not a rectangle, you know, right? This is a cuboid. Yeah. Then what are the formula you want? இப்ப சொல்லுங்க. Very good. How many times pi RL? Very good. Very good. That's all. Repeat. Yeah. You only. Lassie. Not repeat. What do you have with you? Tell me that. Yeah. Say. Very good. How many of you have that answer? 2 into. Very good. LB plus BH plus LH. That's the total surface area. Meaning 2 into LB plus BH plus LH pota TSA of the cuboid கண்டுபிடிச்சிட்டோம். இப்ப அதுல என்ன இல்ல TSA of the cube. What is TSA of the cuboid? The sum of the areas of all the 6 surfaces. 6 surfaces. Imagine the entire cuboidal block. Now the conical cavities are not made. Then they're not made. Okay, so before that, how was the block? It's clean all over and its area is 2 into LB plus BH plus LH. Correct? That's the total area available. Now what's happening? On the top, when you remove the cones, three circle areas, they disappear. They go off with the cone. When you make the conical cavity and remove the cones, the circles on the top, 3 circles are made, right? On the top. So the circular areas, the area equal to 3 circles is missing on the top. But that is included in TSA, no? That's included in TSA. On the top, when you remove the cones, you can see 3 circular edges like this. When you paint, when you try to paint here, there's nothing there. No, on the top, I'm saying there's nothing there. But you've calculated that area. Total surface area means you've calculated the total area on the top. But what is missing? This area is missing. Circular areas are missing. 3 circular areas are missing. So minus 3 pi r square. Because area of one circle is pi r square. So 3 circles, 3 pi r square. Now, some area has been added. Some area has been included. What is that? The conical cavity inside, you have the CSA of the cone. On the top, 3 circles area is not there. But that we have included in 2 into LB plus BH plus LH. Why we are subtracting? Because it is included, you are subtracting. If it was not there, if it's not included in this formula, you will not subtract. When you find 2 into LB plus BH plus LH, it is the total area of all the 6 surfaces of the cuboid. But if on the sixth surface, main of the surface, moon circles illiye. You can't paint there. No? So you'll need less paint, not to paint on the top. The top face, when you have to paint, will you need less or more paint on the top alone? You'll need less paint. No, because three circles are not there. You need lesser paint. That's why you're subtracting 3 pi r square. Then the cavities have some area. The CSA of the cone. That is new. That was not included in the formula 2 into LB plus BH plus LH. That's why you're adding. That's why you're adding. That is new area created, which is not included in this area. So you have to add the area of the curved surface area of the three cones. The cones, they remove three circles. But because you make the conical cavities, three curved surface areas of the cone, you see in this block. This formula includes the total area of the top surface, but three circles have gone missing. They've gone with the cone. So you subtract because it's included in this formula. So you subtract 3 pi r square and you add 3 pi r l because that is a new area created that was not included in this formula. So the expression you will or you should use to find the TSA of the remaining block is 2 into LB plus BH plus LH, which is a TSA of the block. On the top, you have found the total area, but three circles are not there. That's included in this formula. So you should take away 3 pi r square. Some new area is formed. Add that. What is that new area? The curved surface area of the cone. The curved surface area inside. Curved surface area of the cone here also. CS of the cone. Add that. 3 pi r l. Find everything separately. Find this answer separately, this one separately, this one separately, and then add and subtract. You'll get the TSA of the block. All right. So how many of you could make this expression? Now, somewhat understood? Hasib? Behind? I'll give another situation. Now you both have to answer. You three got it? No? No problem. Now you understand? Behind, girls? You have a doubt? It's in words. That's okay. You got it in words. Yeah. Got it now, all of you? No? Okay. Okay. This is another situation. Now, okay, just imagine there is a sphere. A sphere. Now, this sphere has, this sphere, the sphere has 20 hemispherical depressions. You should imagine sphere. Okay. The sphere has 20 hemispherical, like a cup, hemispherical depressions on the surface. Here and there it has. There is a depression, not a hemispherical bump. Not a hemispherical bump like this. A bump will come out of the solid. This is a depression. Okay, so like, it's not a hemispherical bump like this. It's not like this. Okay, it's not like this. It's like on the surface, like it goes inside. There's a depression. So the thing will look like I can't show the 20 depressions, but now hemispherical. Imagine it's hemispherical. Sorry, it is spherical. So the depressions like this, 20 depressions are there. So there'll be some space between the two depressions. There'll be some space. See, this is a depression. There is the surface and then again a depression. So the situation is sphere, solid sphere with 20 hemispherical depressions. What's the surface area of the resulting solid? That is, you originally had a solid sphere. Now you make 20 hemispherical cavities on it. You make 20 hemispherical cavities on it. Now, what's the surface area of the remaining solid? Is the question. Do it. Okay. We'll just wait for the others. Yeah, children. Yeah. I'll ask you later. Somebody online? Why no response? Online children use the emoji. Raise your hand. Okay. Thanks for responding. Okay, so you're all there. Good. Yeah. Who wants to share? You want to say? Yeah, tell me. Just a second. Sorry. I deleted that figure. Is it? I erased the figure. I'm not drawing it again. Yeah, tell me. Come again. You're right, but one word you didn't use correctly. Come again. இல்ல நீங்க ரொம்ப ஃபாஸ்டா சொல்றீங்க. மெதுவா சொல்லுங்க. Area of the sphere. Okay. Oh, you're saying plus area of 20 hemispheres minus area of 20 hemispheres. Huh? அதான் ஓகே. நீங்க அங்க என்னெல்லாம் டேர்ம்ஸ் யூஸ் பண்ணிருக்கீங்க? ஹெமிஸ்பியர், ஸ்பியர் அவ்வளவுதானே? ஓகே. நோ, நீங்க யூஸ் பண்ணிருக்கிறது வந்து வெறும் ஹெமிஸ்பியர், ஸ்பியர் தான். அது தவிர வேற ஏதாவது யூஸ் பண்ணிருக்கீங்களா? ஓகே. மேபி யூ இமேஜின்ட் இட் கரெக்ட்லி, பட் நீங்க கரெக்டான வேர்ட்ஸ் யூஸ் பண்ணாங்க. Anybody else? Asif? ரிப்பீட் பண்ண நீங்க வேர்ட்ஸ் சொல்லுங்க. ஓ சாரி. யா சாரி சார். வேர்ட்ஸ் சொல்லுங்க ஃபர்ஸ்ட். minus 20 what? Minus area of 20 what? அதாம்மா அந்த டிப்ரெஷனுக்கு ஒரு பேர் கொடு. மைனஸ் வேர்ட்ஸ் சொல்லுங்க. இல்லம்மா அந்த அது என்ன பையாஸ் பேர்? கரெக்ட். பேஸ் ஆஃப் தி circle. That word I wanted. That you confused. Circle ன்ற word யூஸ் பண்ண நீங்க. கரெக்ட்டா சொல்லுங்க. So TSC of the sphere only 1 pi r square. So minus area of 20 circles plus how many? Very good. Correct. Yeah. No, you want it first actually. Tell me. Correct. Okay. So the others also might have got it. So that's what it is. First, you consider the total area. What's the total area available? TSA of sphere. This is the total area available. Now, because you're making hemispherical depressions, on the surface, you'll see 20 empty circles, no? Because you're removing, see, to make the 20 hemispherical cavities, we'll have to cut hemispheres. You'll remove it. Hemisphere. You have to make a hemispherical depression. So you'll be removing hemispheres. You'll cut a hemisphere, remove it. When you do that, a circle on the top is empty, right? On the surface, you'll find 20 empty circles. The circle goes away with, see, like in the case of in a solid cylinder, from a solid cylinder, when you make a conical cavity, we saw this in the last class. When you make a conical cavity, what happens? This circle of the cylinder goes away with the cone, no? You have a solid cylinder. You make a conical cavity. When you make a conical cavity, you're making a cone and removing it. You're removing the cone. When you remove the cone, that's when you make a conical cavity. When you remove that cone, what happens? The cylinder has two circular faces. One circular face goes off with the cone. Only one will remain here. In the same way, on the sphere, when you make, is it time? No, right? Okay. So in the same way, on the sphere, when you make 20 hemispherical depressions, that is when you remove 20 hemispheres, along with the hemisphere, 20 circles are gone. So it will be the TSA of the sphere minus, when you find the TSA of the sphere, no, you've included the area of 20 circles. They are now not there. They've gone missing with the hemisphere. The total surface area of the sphere includes the area of the circles, but they're not there now, right? So minus the area of 20 circles. Now, because you've made the hemispherical cavity, some areas been included now, which is the CSA of the hemisphere, So plus CSA of 20 hemispheres. It's as simple as this. You have a box of paint, you have a brush, where all you'll paint, all that you have to compute, that's all. Where all you'll have to paint. Okay, now just imagine like this. You have the solid sphere and you have to paint all over. How much will you paint? 4 pi r square. You have the solid sphere. You'll have to paint it all over. So how much paint you will need? 4 pi r square. Now you make the hemispherical depressions, no? Forget the hemisphere. If you have to paint only the outside, like not the hemispherical depressions, only on the outside, you'll need lesser paint, no? Because some circles are not there on the surface. If you want to paint just on the surface, not in the hemispherical cavity, just on the outer surface, you'll need less paint only, no? Because the circles are empty. That's what we're removing. 4 pi r square is the total area of the sphere, but 20 circles have gone missing. So minus area of 20 circles. Because this area is included in 4 pi r square. That's why you're subtracting. Now some new areas formed, which is not included in this. Some new areas formed, which is a CSA of 20 hemispheres. So this is the formula. CSA of the sphere minus area of 20 circles plus area of, or the curved surface area of 20 hemispheres.
Ma'am.
Yeah.
Ma'am, I have a doubt, ma'am.
Yes.
Can we take instead of CSA of 20 hemisphere, can we take TSA of 20 hemisphere? Because the circles also will include in that moment.
That you will realize only after you use the formula. When this is the understanding. When you substitute, yes, that's what you'll get. You'll get 4 pi r square minus 20 pi r square plus 20 into 2 pi r square. So you'll get 4 pi r square. And this is 40 pi r square, right? 40 minus 20 is plus 20. And this is what you will ultimately get. But you have to start writing like this. This is how you analyze. You can't directly analyze this. This is how you analyze. Yeah, that's what you ultimately get, Aniruddhan. So 4 pi r square plus minus 20 area of 20 circles, 20 pi r square plus CSA of 20 hemispheres. So 20 into CSA is 2 pi r square. So 4 pi r square minus 20 pi r square plus 40 pi r square. So plus 40 pi r square minus 20 pi r square is plus 20 pi r square. All right, and what is 20 pi r square plus 4 pi r square? 24 pi r square. That's all. So you can't write 24 pi r square directly. You should come from here, no? All right. 20 pi r square and 4 pi r square is 24 pi r square. That's the answer. Yeah, this is self-help. Do this and then we'll discuss. I'll ask you questions. Read the question, understand the question, work the answer. Then I'll ask you questions, I say. Based on the answer, I'll ask you questions. Yes, Sakshada, you're right. Good, good. Yeah. These values I don't think are visible. I'll just see this one is 26. This one is 6. Here the circle, the inner one is 3. This one is 3. And the outer one here is 5. All in centimeters. Here it's written base of the cylinder. This is the base of the cone. Base of cylinder. Base of cylinder. That's what is written there. And base of cone. Is it working? The children calculations, yeah, I see her working sincerely. Others I didn't notice. I went that side, so I saw her, but the others, have you calculated? Have you done the calculations or just taken it from the screen of the board? Perform the calculations. All right. Memorize all the values. You will not see the. You will not see your book and answer. Memorize the values. All right. Okay. Okay. So in the question, the rocket is a combination of a cone and a cylinder. Online children, please participate. Yeah, the rocket is a combination of a cylinder and a cone. Now, does the circular top of the cylinder and the circular base of the cone coincide in the rocket? In this rocket, does the top, the circular top of the cylinder and the circular base of the cone, do they coincide? என்ன அப்படி பாக்குறீங்க? புரியலையா என் question? My question you don't, that's what you should answer that. Either answer the question or say you don't understand the question. I'll explain. Yeah, see here. This is the cylinder, right? Then on the top there is a cone. Not so big. On the top there's a cone like this, right? This is the base of the cone. The base of the cone sits on the top of the cylinder here, right? My question is, do the circular edges of the cone and the cylinder, do they coincide? Is it like this? Is the rocket like this? No, it's not like that. The circular edges of the cone, that is the base of the cone, and the top of the cylinder, the circles, they don't coincide. Then which circle, which base is larger? Cone's base is larger. The cone's base is larger. So when this cone is made to sit on the cylinder, its base is larger, right? So it will come out. It will come out now. I'm just making a rough thing, okay? So it will come out. This one, it will be outside. It will not be straight like this, but it will be outside the cylinder, right? So when you look under the rocket, when you look at this portion of the rocket, when you look at this portion of the rocket, you will find this one is the circular part of the cone. This is circular part of the cylinder. This portion you can see. This is the portion that you will see at the base of the cone. At the base of the cone. See, again, it's your imagination. So cylinder, on top of that is a cone. The base of the cone does not coincide with the base of the, does not coincide with the top of the cylinder. So the cone spreads outside, right? So when you look underneath this portion, when you look underneath here, you will see one circle, the base of the cone, but you will not see the base of the cone completely because it's stuck to the top of the cylinder, right? So you will see this area. Underneath here, you will see only this area. Is that, I imagine that or no? Same figure is only length in a toes. You go home and do that activity. Okay, so take something conical, maybe, if you use that in the puja room, like that, the samrani powder, which is stuffed inside the cone and, which is burnt in front of God. So you can, that cone, you can try to put it on a pencil. And you can see take a thin pencil and a big cone and try to put it like that and see underneath what you can see. Anything conical, put it on a pencil, something conical. I think that cone should be, the base of the cone should be broader than the top of the pencil. Just keep a cone, take a pencil, an unsharpened pencil, and put a conical thing on the top and see how it looks underneath. Then you will understand. So you will see this ring. Underneath, you will see this ring. And what's the area of this ring? Pi capital R square minus small r square. That's how we find the area of the ring. Because it's the area of the outer circle minus the area of the inner circle. Area of the outer circle is pi capital R square. Area of the inner circle is pi small r square. So pi common capital R square minus small r square. Okay, so rocket, cylinder, cone, base of the cone spreads out of the top of the cylinder. So underneath you can see this portion is of the cone. It's not of the cylinder. This one which is spread out is of the cone. It's the cone's portion, not the cylinder's portion. It's the cone's portion, correct? Okay. So now what are the different surfaces you see for the cone? You can see the curved surface area of the cone, and this base ring is of the cone. This base ring is of the cone. It's not the cylinders. Because one thing is painted yellow, the other is painted orange. Who's painted yellow? Cylinder yellow. Okay. So the cylindrical portion is painted yellow. The conical portion is painted orange. So which are the surfaces that belong to the cylinder? Which are the surfaces that belong to the cone? So the surfaces that belong to the cone are the curved surface of the cone and this ring. This ring belongs to the cone. Two surfaces of the rocket belong to the cone. the CSA of the cone and the base ring of the cone. These two belong to the cone. CSA of the cone and the base ring. These two belongs to the cone. For the cylinder, again, CSA of the cylinder and the base bottom area, this area. The top area, no, you want to paint, but you can't paint because the cone is stuck on the top. So the top area is not visible. The top area of the cylinder is not visible to be painted. It's not there. You can't see that. You can't see the top of the cylinder because the cone is stuck to it. So you can't paint the top of the cylinder, but you can paint the CSA of the cylinder, and you can paint the bottom of the cylinder. You can paint the bottom circle of the cylinder. You can paint the curved surface area of the cylinder. You can paint. You want to paint the top of the cylinder, but you can't see it at all. It's not exposed. You can't see it. Then you can't paint. No. So what you can paint for the cylinder? CSA of the cylinder and the bottom circle of the cylinder. These are the two surfaces of the cylinder which can be painted. And the two surfaces for the cone which can be painted are CSA of the cone and this bottom portion, which is coming out of the cylinder, which is a ring. Okay, whose area is pi cap r square minus small r square. So for the circle, it is pi RL, which is a CSA, and pi cap r square minus small r square, which is the area of the base. This is of the cone. For the cylinder, CSA is 2 pi RH, and the bottom area is pi r square. These two is of the cylinder. So you will paint the cylinder orange, I think, and the cone yellow. Whatever, cone yellow. So cylinder. Okay. Cylinder. Okay, cylinder has Y, so yellow. One has O, so orange. All right. So like this. Is this understood? So okay. Now, what's the height of the? What is the height of? Oh, I forgot. What's the height of the cone? Don't see your book. Don't see your book. What's the height of the cone? 6 centimeters. What is the height of the rocket? 26 centimeters. What's the height of the cone? I'm sorry, what's the height of the cylinder? 20. Because when we say height of the rocket, it is the height of the cylinder plus the height of the cone. Height of the cylinder plus the height of the cone together is 26. Minus the conical height, 6. The remainder, 20, is the cylindrical height. So 6 is the height of the cone, 20 is the height of the cylinder. What about the diameter of the cylinder? Diameter of the cylinder? 3. Diameter of the cylinder is 3. What's the diameter of the cone? 5. 5. This one is the diameter of the cylinder. It's stuck there, no? This is the diameter of the cylinder. This is the diameter, this one. This one is of the cone. That's what you see here. See, this one, this outer, this one is of the, this one is of the cone from here to here, 5. And from here to here, this one is of the cylinder, 3. On the top, see, it's difficult for me to draw. I really cannot do it. See, this is, if there's a good artist here. Okay. Mine looks like a mushroom, conical mushroom. I seriously don't know how to represent, but I'll just. Okay. All right. This is the diameter of the cylinder, 3. This one is the diameter of the cone, 5. That's what is shown here. That is what is shown here. This one is 5. And this one is 3. This one is 3. So the diameter of the cylinder is 3. The diameter of the cone is 5. So radius is 2.5 and 1.5. So for the cylinder, radius is equal to 3 by 2, 1.5. height is equal to, for the cylinder, 20. For the cone, radius is not the same. It's different. It's more. It's 2.5. And the height of the cone is 6. This 26 will not be used anywhere. This 26 height, no, will not be used anywhere. For the cylinder, you will use these two values. Radius 1.5, height 20. For the cone, you will use radius 2.5, height 6, and you'll have to find the slant height because pi RL, no, so you'll have to find the slant height. So this number 26 will not be used anywhere in the calculation. So you should be clear about the values or the parameters we use for cylinder and cone. Radius, height, slant height. You must write these carefully. நீங்க வந்து கொஸ்டினை பார்த்து அப்படியே ஃபில் பண்ணிக்கலாம் அப்படின்னு இதை எழுதாம நீங்க டைரக்டா ஆன்சர் போனீங்கன்னா you will definitely go wrong. So that's why I colored the table also. See, when I prepared it, I colored it because I wanted to tell children that this is important. This one is important. For the cylinder, radius is 1.5. And for the cylinder, I've taken a capital H because the height is more. No? So I've taken a capital H, 26 minus 6, 20. And for the cone, the radius is more. So I've differentiate pannolla. And then I've taken a capital R because radius just the cone 2.5 and the height P in the confusional learning R1, H1, R2, H2. For the cylinder, you can take R1, H1. For the cone, you can take R2, H2. Not that you should use capital and small correctly. And there's also the ring. Yeah, not to forget that. There's also the ring. Capital and smaller. This one only. So write these values, then find the slant height, and then start with this one. So area to be painted orange is the cone's portion. Area to be painted yellow is the cylinder's portion. So here I've used a square minus b square. I didn't do 2.5 into 2.5. I think I didn't do 2.5 into 2.5, 1.5 into 1.5 and subtracting. So a square minus b square is a plus b. What is a plus b? 2.5 plus 1.54 into a minus b. A minus b is 2.5 minus 1.5. So 1. So 4 into 1, 4. A square minus b square is a plus b. 2.5 plus 1.54 into a minus b. 2.5 minus 1.5, which is 1. So 4 into 1, 4. So that's what 4 per. Even if you subtract 2.5 into 2.5, 6.25. 1.5 into 1.5 is 2.25. When you subtract, you'll get 4.00, which is 4. Yeah, you should ask me anything else. Any other doubt you have or you had while working? And I've seen children, volumes and surface area chapter முடிக்கிற வரைக்கும் ஃபார்முலாவே மெமரைஸ் பண்ணிருக்க மாட்டோம். ஃபார்முலா பக்கத்து வச்சு அப்பப்போ பார்த்து எழுதிட்டு சாப்டரே முடிச்சிருப்போம். ஆனா இல்ல ஐ நோ எவ்ரிதிங் பட் ஃபார்முலா தெரியாது. I'll find out what jokes or statements will make you laugh under the. I'll find out and then talk like that, okay, so that I can even engage you in the class. Yeah. So please memorize the formulae. Like, how many of you know the formulae involved in this chapter? You. Okay. No? You want to revise? No? தெரியுமா? Okay, Bhavishya, sure. What about the others? Blessy? Forgot. Okay. Okay, fine. Anything else that I should discuss? Yeah, now here one thing I want to clarify is that in this question, See, when we find CSA, like the curve, supposing you have a cylinder, and we are asked to find the curved surface area of the cylinder. Supposing cylinder it's like this, it's a hollow cylinder. Supposing it's a hollow cylinder like this. Okay, so it's a hollow cylinder like this, and you have to find the CSA. What will you do? 2 pi RH, no? 2 pi RH. You will find only this. But inside also there's CSA, no? So supposing you have to paint this. Supposing you have to paint this. And you have to find the total area to be painted. Yeah, CSA, but into 2. Because when you find 2 pi RH, you're finding only for the outer one. If you're asked to find the curved surface area of the cylinder, this one is 2 pi RH. That's correct. But if you have to paint the cylinder from inside and outside, it's because it's open, no? If you want to paint the cylinder from inside and outside, you want to paint inside and you want to paint outside also, then it's not enough if you find 2 pi RH. This is 2 pi RH. This is also 2 pi RH. The 2 pi RH into 2 is what you should paint. That area is what you'll have to paint. So remember, whenever we find area, no, we are finding area only for the outer or the inner surface. When the radius is the same, that is when the wall is not thick. If the cylinder wall was thick, see, again you should imagine when if the cylinder wall is thick, you know, then the inner curved surface area and the outer curved surface area value will be different. I'm pausing so that you internalize. When the wall of the cylinder is thick, as in the case of a sellotape, you buy a new sellotape roll from the shop. It's a cylinder where the wall is thick, right? It's a hollow cylinder like this it will be, but the wall is thick. Formula to find CSA is 2 pi RH. Formula to find CSA of a cylinder is 2 pi RH. But to find inner CSA, you will use 2 pi smaller h. And to find outer CSA, you'll use 2 pi capital RH. The height will be the same. The height will be the same of the cylinder. But when the wall is thick, inner CSA you will find using inner radius. Outer CSA you will find using outer radius. The inner CSA and the outer CSA of a cylinder is the same if the wall is thin. That means the inner radius and the outer radius is almost the same. See, now the inner radius, the outer radius, both will be the same because the wall is so thin. If the inner radius and the outer radius is the same, then the inner CSA and the outer CSA is also the same because the radius is the same, the area is also the same. But if the wall is thicker, then you will have two radius. One inner radius you will have, one outer radius you will have. So inner CSA will be 2 pi small r h and the outer CSA will be 2 pi capital R h. H is the same, the height of the cylinder. So ulla paint pandrathu vandu this one, inner CSA. This one. Outside painting is this one. Of course, there are other surfaces also. In this case, there will be other surfaces to be painted. But what I'm trying to convey through this is, whenever you find area, you're finding either inside or outside. You're not finding both, is what I'm trying to say. Whenever you find area, you're either finding for the outer region or the inner region, not for both. Okay. Now you'll understand why is she saying all this. Now this is the bird bath. There's a bird bath. So you can see it's a stand. Like in the garden, if you have a garden or in the terrace, you keep water in this so that, you know, during summers, so we are thirsty, we go and we get water, but the birds and other small animals which visit your terrace or your garden, you know, they come in search of water, right? Earlier, taps or dripping taps, animals go under that and drink. So now it's dry everywhere, no rivers. Lakes are converted to palatial apartments, right? No lakes, no rivers, everything. We can go and live. And So we're trying to capture nature. We're trying to win over nature. And nature comes back, gives it back in the form of floods. Right? So who's powerful? Powerful, not man. Nature is always powerful. So people who connect with the nature, connect with animals, you can see they leave a vessel of water so that animals, birds can come and, drink during the summer season where they can't find water anywhere because it's dry everywhere. So that's what is a bird bath. So this bird bath, you'll have to, so how is it? You can see like a tripod stand. You can see the 3 legs here. You can see the 3 legs. Okay, you can see the 3 legs. It's actually hollow here. It's hollow here. Now this is the cylindrical part, and there's a hemispherical depression. Hemispherical depression. Hemispherical depression. Okay. Now the question is to find the TSA of the bird bath. So you're finding from the outside. I told you, whenever you're finding area, you're finding only. See, when you're asked to find, that's why I gave this example. Because நீங்க டவுட் கேட்டு நான் சொல்றதுக்கு நான் முன்னாடி உஷாரா ஒரு சிச்சுவேஷன் கொடுத்துட்டா எனக்கு ஈஸி. இப்போ இந்த சிலிண்டர் இப்படி ஒரு சிலிண்டர் இருக்கு. இதுக்கு நான் கர்வ் சர்ஃபேஸ் ஏரியா கண்டுபிடிங்கன்னா நீங்க என்ன பண்ணுவீங்க? 2πRH மட்டும் தானே பண்ணுவீங்க. அப்படின்னா வெளியில மட்டும் தானே கண்டுபிடிப்பீங்க. Unless I give you a situation that you have to paint it. You have to paint wherever it is, wherever you can paint, you should paint. Apdina you will find 2πRH and into 2 you will do. Because inside area is also 2πRH. Otherwise, you will find only from the outside or inside. So outside, what do you see of the cylinder? CSA of the cylinder, outside. Because I told you, this is empty. Under this, it's empty. You only have the stand. And the stand area we cannot find. Because nothing is given about the stand. No, for the stand, they've not given you anything. So you cannot find the area of the stand. So what you have the cylinder. From the outside, what do you see of the cylinder? CSA. And then the depression, the hemispherical depression. So it is 2πRH plus 2πR square. That's all. Now, if your question is, now for the stand, I told you very clearly. For the stand, I told you very clearly, nothing is given about the stand. So you cannot find the area of the stands. That we can't find. Now I'm saying like below here, it's open. The cylinder is open. But we'll not find that area because we'll always find area from externally or internally. We'll not find both. So from the outside, the area of the bird bath, from the outside, when you look at the bird bath, from the outside, what do you see? Forget the stand. What do you see? You see the CSA of the cylinder, 2πRH. You see the CSA of the cylinder, which is 2πRH. Bottom, it's open. The circle is open. There's no material there. So no area you can find. So you see the CSA of the cylinder. And on the top, if you look inside, you see the hemispherical depression, which is 2πR square. CSA of the hemisphere, which is 2πR square. That's all you see from the outside. அவ்வளவுதான் surfaces தெரியும். வெளியில நீங்க bird bath பாத்தீங்கன்னா ரெண்டு surface தெரியும். சிலிண்டரோட CSA தெரியும். அப்புறம் that bowl, the CSA of the hemisphere. These are the two surfaces you can see. 2πRH is for the cylinder, 2πR square is for the hemisphere. That's all. Add both. Everything else is given to you in the question. Radius. So in this case, the radius of the hemisphere and the radius of the cylinder is the same. The radius of the cylinder and the hemisphere is the same. Yeah, good. You can also calculate by taking out 2 pi r common, children. 2 pi r h plus 2 pi r square. You can take out 2 pi r common and h plus r. You can also do it like this. Finished? Finished? So you can work it like this by taking out 2 pi r common, or like here I've substituted the values. I've not used the value of pi. Once for all, I've used the value of pi here. And yeah, I think the question is to find it in meters square. Oh, in the question, it's in meter here, no? This is in meters, so I've just converted. Okay, now if your doubt is, why can't we leave it here? Should we convert it? You can leave it here. You can leave it here. It's not mentioned anywhere that you have to find the answer in meter square or centimeter square. So you can leave your answer here. Okay, so I have converted it to meter square. So how do you convert centimeter to meter? Centimeter to meter, you have to divide by 100. Centimeter square to meter square, divide by 100 2 times. Centimeter square to meter square. Whatever you do it 2 times, that's all. Centimeter to meter, you divide by 100. Centimeter square to meter square, another 100 you should use. 100, so 10,000. Okay, so answer this question. That's all about the volumes and surface area for today's class. This is from real numbers, but not that you should have learned the chapter in school. This is also of number systems of 9th standard. Now tell me, is cube root of 189 divided by cube root of 7 a rational number? The question is cube root of 189 by cube root of 7 a rational number? If yes, why? If no, why? Yeah, tell me. Is it in the P by Q form? Yeah, so think like that. Rational numbers must be in the P by Q form, right? Yeah. Is this a rational number? If yes, why? If no, why? How many of you have learned? No, this is not got anything to do with real numbers of 10th standard. This is of number systems 9th standard. Even if you are in 8th standard, you can do it because rational number, you know, and square roots and cube roots we also learn in class 8. Yeah. This is food for the brain. This is brain food for the brain. Yeah. Yes. It is a rational number. Why? Cube root of? Okay, which is? Very good. You're nodding, meaning you also got it. Oh, no, no. I'm asking you, Mritsa. Huh? Oh, okay, okay, okay. Correct. So you need to simplify. See, the first thing is you cannot say this is of the P by Q form. This is not of the P by Q form. What is P by Q form? Integer by integer form. What is P by Q form? Who's that? Oh, hey, hi. How are you? You live in Chennai, right? Yes. Okay. Here for vacations. Very good, very good. Okay, okay. Just 2 minutes. I'm winding up the session. You can wait. You can wait. Yeah. So P by Q form is what? Integer by integer form, right? Integer by integer form. Is this an integer? Is this an integer? No. Is this an integer? So simply because it is something by something will not make a rational number. Something by something is not a rational number. Or P by Q. Okay, what is P? What is Q? P should be an integer. Q also should be an integer. Integer by integer is a rational number. So you cannot say that this is of the P by Q form. It looks like that maybe, but is the numerator P an integer? No. Is the denominator Q an integer? No. So with that reason, you cannot say it is a rational number, but that's not the reason. You can't say it's of the P by Q form because it is not of the integer by integer form. Then how is it a rational number? You need to simplify. So cube root of A by cube root of B can be written as cube root of A by B. Cube root of A by cube root of B can be written as cube root of A by B. All right, I'll just clear the screen for clarity. 189 and 7, right? 189 and 7. Okay, so we are simplifying this. It's cube root of 189 by 7. So simplify. 7 ones are 7 twos are 14. 4 remains. 7 sevens are 49. So it is cube root of 27. And the cube root of 27 is 3. And 3 is 3 by 1, which is P by Q, integer by integer. So this one is a rational number. So this is a rational number. So you must always simplify. Just by looking, you shouldn't say. You must simplify. Upon simplifying, it is 3, which is 3 by 1, P by Q. So the given number or the given expression is a rational number. Very good, Bhavishya. Okay. Okay, so that was food for the brain. Now you got it, all of you? Easy, right? All of us could have done it. Just didn't realize that we had to simplify it like that. Probably we didn't realize that we can simplify like cube root of 189 by 7. Maybe we didn't realize this. Yeah, you can do it. All right, children. So that's it for today's session. Thank you so much. Good night. Online children can leave the call. Thank you. Good night.
Thank you,
Thank
ma'am.
you.